Welcome to Max Mathematics class. In today's class, we are going to look at 3 ways to solve this exponential equation. Relax yourself and enjoy the class. Method 1. We are going to rewrite the left-hand side of this equation in its negative form. That is, 81 will be written as 81 raised to the power of minus 1 times x minus 2 in brackets and is equals to 27 raised to the power of 1 minus x in bracket. So if you look at the law of indices, law number 7, negative exponent law, we have a raised to the power of minus n, and that is the negative aspect of it. So the positive aspect is 1 over a raised to the power of n. This is the same law we applied here. So after this, we are going to rewrite 81 and 27 in their index forms. That is, 81 will be written as 3 raised to the power of 4. Now this 4 will multiply this minus 1 to give us minus 4. So we have 3 raised to the power of minus 4 times x minus 2 in brackets and is equal to 27 will be written as 3 raised to the power of 3 times 1 minus x in brackets. So the index form of 81 is 3 raised to the power of 4. Now if you check the number in index form chart, we have this 81 to mean 81 to be equal to 3 times 3 times 3 times 3 times 3. That is 4 places. We now have 3 raised to the power of 4. Now this 3 raised to the power of 4 is the index form of 81. Likewise, 27 will be 3 times 3 times 3, and that is 3 raised to the power of 3. So the index form of 27 is 3 raised to the power of 3. So it's the same thing we applied here. So after this, we are going to clear the base. These 3 cancel out this. So we are now left with the power of 3 in the left hand side will become minus 4 times x minus 2 and is equal to 3 times 1 minus x. Now after this, we are going to remove the bracket. In removing the bracket, we have minus 4 times x to give us minus 4x, and minus 4 again to times this minus 2 to give us plus 8, and is equal to 3 times 1 to give us 3, and 3 times minus x to give us minus 3x. So we are now going to collect the like terms. In collecting the like terms, we have this minus 4x and then minus 3x. Again, they are like terms. Now, minus 3x, when moved from the right-hand side of the equation to the left-hand side, it will become plus 3x. In the left-hand side, we have 3, and plus 8. If we move it to the right-hand side, it will become minus 8. So, if we simplify minus 4x plus 3x, it will give us minus x, and it will be equal to 3 minus 8 to give us minus 5. So we can divide both sides now by the coefficient of x, which is minus 1. So we divide here by minus 1, here also by minus 1. So that this minus will cancel out this, and this minus also cancel out this. So we now have our x to be equal to 5. In conclusion, therefore, x now is equal to 5. So this is method 1. And it is called negative method because we rewrite the left-hand side of the equation in its negative form. So let's move to the next method. Now, in the next method, we are going to, which is a positive method, instead of writing this left-hand side in the negative form, we are going to clear the fraction here so that we now have 1 to be equal to 81 raised to the power of x minus 2 times 27 raised to the power of 1 minus x. Now we are going to apply this law of indices, this law number 1, product law. That is, if you have a raised to the power of m times a raised to the power of n, it will be equal to a raised to the power of m plus n. This will only happen if the bases are equal, and if you check here now, the bases are not equal. So we have to make it equal by writing 81 and 27 in their index forms. Again, we are going to apply this law. Any number raised to the power of 0 is 1. So this one now we can write it as 3 raised to the power of 0, and it will be equal to 81 will be 3 raised to the power of 4 times x minus 2 that is already there, times again 27 is 3 raised to the power of 3 times 1 minus x that is already there. So from the index form chart, you can see the index form of 81 is 3 raised to the power of 4, and the index form of 27 is 3 raised to the power of 3. So after this, we are going to continue by writing 3 raised to the power of 0 equal to 3 raised to the power of 4 times x minus 2. So this multiplication can become plus because of the product law we showed you. So here now we have 3 again times 1 minus x. So we do this so that we can clear the base. So this cancel out this. We are now left with 0 to be equal to 4 times x minus 2 plus 3 times 1 minus x. So it is now time for us to remove the bracket so that 0 now will be equal to this 4 times x will give us 4x, and this 4 again times minus 2 will give us minus 8, plus 3 times 1 will give us 3, and 3 again times minus x will give us minus 3x. So after this, we are going to collect the like terms. From the diagram, the like terms are 0 equal to 4x and minus 3x are like terms. Again, minus 8 plus 3 are also like terms. So if we simplify them, we have 0 to be equal to 4x minus 3x can be simplified to x. That is 4x minus 3x will give us x. So it can be simplified to x. Then minus 8 plus 3 will give us minus 5. So if we move this 5 to the left-hand side of the equation, we are going to get 5. We are going to get plus 5, and it will be equal to x. So x cannot remain in the right-hand side of the equation, so we have to move it to the left back. We are moving it not to change the sign, but to swap the position with 5. So this will be equal to 5. So in conclusion, therefore, our x now will be equal to 5. So let's move to the last method. In this method, we are going to rewrite 1 here as 3 raised to the power of 0 over 3 raised to the power of 4 times x minus 2. And it's equals to 27. Here we'll write it as 3 raised to the power of 3 times 1 minus x. Now we call this method 0 method because this one has been converted to 3 raised to the power of 0. So after this, we are going to apply the division law of the quotient law of indices, which is the same thing as division law of indices. So this is the law. If you have a raised to the power of m over a raised to the power of n, you are going to have a raised to the power of m minus n. So we are going to apply this law now to the left-hand side of this equation, so that we now have 3 raised to the power of 0 minus 4x minus 2, and is equals to 3 raised to the power of 3 times 1 minus x. Now, we do this so that we can clear the base, so that this cancel out this. We now have 0 minus 4 times x minus 2 in brackets, and is equal to 3 times 1 minus x in bracket. So we are going to remove the bracket. Remember, this is still the same index form chart. So 81 is the same thing as 3 raised to the power of 4. 27 is the same thing as 3 raised to the power of 3. Now this 3 is as a result of 3 times 3 times 3. We have the 3 at the power. Now this 4 is as a result of 3 times 3 times 3 times 3. 4 times. So we'll give us this 4. Now after this, we can now remove the bracket. By removing the bracket, remember 0 minus the whole of this will give us minus 4 x minus 2, and is equal to 3 times 1 minus x. So if we remove the bracket, we are going to have minus 4x plus 8, and is equals to 3 minus 3x. Now if we collect the like terms, we have minus 4x in the left hand side and minus 3x in the right hand side. If we move it to the left hand side, it will become plus 3x, and it will be equal to 3 in the right hand side, and if we move this plus 8 to the right hand side, it will become minus 8. So if we simplify minus 4x plus 3x, it will give us minus x, and it will be equals to 3 minus 8 to give us minus 5. So we are going to use the coefficient of x, which is minus 1, to divide both sides of the equation. So here we divide it by minus 1, here also by minus 1. So we are going to clear the minus. This minus cancel out this minus also cancel out this. X now will be equal to 5. In conclusion, therefore, our x is equal to 5. Thank you for watching our video. In case you have not subscribed to our channel, please subscribe.